In 1974, ornithologist Don Merton was granted permission for one final expedition into the mountains of Fiordland, New Zealand. His job is not to find anything. His job is to confirm that there is nothing left to find. In the 25 years before that morning, the Wildlife Service had sent 61 separate expeditions into those mountains looking for the same bird. 6 had been found. 5 of them were already dead by the time anyone reached them. Merton was sent to write the obituary. Instead, he found 18 of them alive. Then, on a second island, the booming calls of around 200 more. For a moment, it looked like a miracle. It was not. Every single one of them, every bird on both islands, turned out to be male. A population that cannot reproduce is not a population. It is a countdown, and nobody yet knew how much time was actually left on the clock. I'm Whitmore, and this is the story of how a bird that survived 60 million years without a single predator was driven to the edge of extinction in under 2 centuries. How the rescue meant to save it kept failing in ways nobody could have predicted, and how a discovery in 2015 overturned something science had assumed for decades, right before a mistake in 2002 nearly undid everything the program had built. By the end of this video, you'll understand why the most important breakthroughs in this entire 50-year rescue did not come from doing more. They came from a parrot patiently teaching a team of scientists exactly how wrong they were, one failure at a time. To understand why this bird needed saving at all, you have to understand what it actually is, because it does not behave like any parrot you've ever seen. The Kakapo, Strigops habroptilus, is the largest parrot on the planet, a flightless nocturnal giant that can weigh up to 4 kilograms and live for a century. For 60 million years it existed in New Zealand with no mammals on the ground at all, no teeth, no claws, nothing hunting it from below. It never developed an instinct to fear the forest floor because the forest floor had never once tried to kill it. Then humans arrived, and not long after, so did the animals humans always seemed to bring with them. Cats, rats, stoats. The Kakapo had no defense because it had never needed one. It did not run. It did not hide particularly well. By the time anyone understood what was happening, the bird was already vanishing from almost everywhere it had ever lived. The only reason it survived at all is that the most remote, most punishing mountain valleys in the country stayed predator-free a little longer than everywhere else. That's where Merton found his 18 males in Fiordland between 1974 and 1977. And it's where the search moved next, 160 kilometers south to Stewart Island, where the booming calls of roughly 200 more birds echoed through the bush. Still no females. For 3 more years, the team kept looking. And then in 1980, a hunting dog led its handler to something tucked between a knot of tree roots. Smaller, slimmer, a different shade of green, a female. The first one confirmed in decades. Within months, 4 more turned up, some of them already nesting, already raising chicks. The species could breed after all, but Stewart Island had its own clock running. Feral cats were tearing through the population faster than it could recover, so between 1980 and 1997, the birds were moved, one careful transfer at a time, onto islands the team believed could finally be made safe. This became the foundation of the 1995 program. And almost immediately, the islands started raising questions nobody had answers to. Because island sanctuaries were not a new idea. Back in 1894, a conservationist named Richard Henry had tried almost exactly this, moving nearly 400 Kakapo onto Resolution Island in Fiordland, the world's first attempt at an island sanctuary for an endangered bird anywhere on Earth. It should have worked. In 1900, stoats swam the channel separating the island from the mainland and wiped out the entire population within a few short years. Henry watched the project he'd given everything to collapse in front of him. The 1995 team had absorbed that lesson. They chose islands farther offshore, scoured them clean of predators, controlled every piece of equipment and cargo that came ashore. What they didn't remove was rats. Rats weren't considered a serious threat. They don't kill adult Kakapo. Nobody expected them to matter much. That assumption turned out to be the first thing the bird would prove wrong. Rats never touched the grown birds, but they found the eggs and they found the newly hatched chicks, and data from the islands eventually showed they were disrupting close to a third of every nesting attempt. Of the 12 chicks that hatched across 3 different islands between 1980 and 1995, only 3 survived. The birds were nesting. The eggs simply weren't making it. Once the team understood that and finally cleared the rats out too, you'd expect the story to turn a corner right there. It didn't. The Kakapo kept refusing to nest, and for years, nobody could explain why. The team tried the obvious fix. They built supplementary feeding stations and developed dense nutrient pellets, engineering the most complete artificial diet anyone had ever designed for an endangered bird. The Kakapo ate all of it. They looked healthy, body condition scores climbed, and they still, overwhelmingly, refused to nest. It turns out the Kakapo doesn't breed on anything resembling a normal schedule. It waits for a single tree, Rimu, a New Zealand podocarp pine that can live for 500 years, only mass fruits once every 2 to 6 years, and a female Kakapo will not begin nesting until she has seen enough of that fruit on the branch, no matter how much other food sits in front of her. For decades, biologists assumed this was simply behavioral. Birds respond to abundance, the thinking went, so give them abundance and they'll respond the same way regardless of the source. They didn't. Every season without a Rimu mast was a season with almost no nests at all, no matter what the team put in the feeding stations. The bird was holding to terms nobody outside its own biology had ever written down. The answer, when it finally came in 2015, didn't just solve a Kakapo mystery. It overturned something biologists had assumed for years. Researchers at Massey University analyzed Rimu fruit and found it was extraordinarily dense in calcium, exactly what's needed for egg formation and chick skeletal growth. But they also found both forms of vitamin D sitting inside it, including D3. At the time, D3 was considered an exclusively animal-derived compound. The textbooks said plants simply didn't make it. Rimu did anyway. For a female who forms eggs and raises a chick completely alone, with zero help from the male for months at a stretch, this wasn't a dietary preference. It was a molecular trigger her body needed before reproduction could even start. No artificial pellet, no matter how scientifically engineered, could replace something nobody on the team had known they were supposed to be replacing. The lesson buried in that discovery was almost unbearably simple. You cannot out-engineer 60 million years of evolved biology by guessing. You have to actually find out what the animal is responding to. And just 3 years before that answer arrived, the program had already learned an even harder lesson, the kind that comes from getting something right and watching it backfire anyway. In 2002, Codfish Island finally produced a heavy Rimu mast for the first time in several seasons. The team saw the opening and went all in, intensively feeding every breeding female to bring her into the best possible physical condition before nesting. The logic seemed airtight. Healthier females mean more eggs, and more eggs mean more chicks. More chicks did arrive. But when the team counted the sexes afterward, 70% of them were male, in a species where males already outnumbered females by a wide margin. The well-intentioned intervention had just made the single worst problem in the entire recovery worse, using the program's own hands. It took biologists a while to work out why, and the mechanism, once they found it, was pure evolutionary logic working directly against the recovery. Male Kakapo grow 30 to 40% larger than females and cost considerably more in resources to raise. A female in excellent condition, evolution has decided, gets a better long-term payoff investing in the larger, costlier sex. It's a strategy that makes sense for a healthy wild population. For a tiny, critically endangered one trying to claw its way back from 51 birds, it was close to sabotage. The fix the team landed on was almost the opposite of every instinct conservation biology usually runs on. Feed the females less, not more, just enough to support a healthy nest, with no surplus left over to invest in extra sons. At that lower threshold, the sex ratio swung back toward roughly even. It marked the first time in recorded history that researchers had deliberately shifted the sex ratio of an entire species' offspring through nothing but a change in maternal diet, and the population grew 39% that single season, not because the team fed the birds more, but because they finally learned to feed them with precision instead of generosity. From that point, the climb became real, even if it stayed painfully slow. Every year the Remu fruited, the population edged forward. 2005 brought a handful of chicks. 2009 brought more, and the total crossed 100 individuals for the first time, then 150 a few years after that. Every mast-free year was simply a pause, the population holding its breath until the next opening. By 2016, the population had doubled against the 1995 low. Within 6 more years, it had doubled again. Somewhere in that stretch, the program did something that had genuinely never been attempted before for any species on Earth. They sequenced the complete genome of every single living kakapo, not a representative sample, every individual bird plus several of the dead. What came back was not encouraging. The entire surviving population carried just 36 distinct genetic lineages. The widely accepted threshold a species needs to survive a severe population bottleneck long-term is 50. The Kakapo would never cross that line, not because of bad management, but because the raw genetic material to cross it simply no longer exists anywhere on the planet. Those 51 birds in 1995 were the entire remaining gene pool. Every one of the 236 alive today descends from them, and there is nowhere left to draw new diversity from. Rangers were no longer just managing a population anymore. They were managing the evolutionary trajectory of an entire species, one planned pairing at a time, transferring eggs between nests so a chick could be raised with genetics as different from its biological mothers as the remaining pool allowed. The technology built to support that level of precision eventually moved well past anything resembling traditional fieldwork. When a female settles onto an egg, rangers sometimes quietly swap it for a replica built by Weta Workshop, the same studio behind the props in The Lord of the Rings, 3D printed, correctly weighted, fitted with a speaker that begins calling at just the right developmental stage to prepare the mother for a chick's arrival. The real egg goes into a climate-controlled incubator with dramatically higher survival odds, and once the chick is ready, it gets returned and the female accepts it without hesitation. It's not a trick for its own sake. It buys the mother enough recovered strength to nest a second time in the same season if the Remu holds. In 2019, 30 females did exactly that, nesting twice in a single mast year, and it produced a record-breaking 73 fledglings, by far the best season the program had ever recorded. For about 5 minutes, 2019 looked like the year everything finally clicked into place. Then aspergillosis appeared on Codfish Island. It's a fungus that exists almost everywhere in the environment, harmless to most healthy birds whose immune systems handle it without effort. The Kakapo's decades-long genetic bottleneck, combined with the unusually dense nesting concentrations the recovery program itself had created, left them far more vulnerable than anyone had braced for. 21 birds were infected. 9 died, a mix of adults, chicks, and juveniles. 51 birds, the exact same number that had survived the entire bottleneck back in 1995, had to be evacuated to mainland veterinary facilities for treatment. The outbreak was eventually contained, but it confirmed exactly what geneticists had been quietly warning about for years. With the whole species crowded onto a handful of islands and sharing one thin genetic foundation, a single disease outbreak on a single island could undo 3 decades of work in a matter of weeks. That single brutal season is the reason the program started looking, seriously, at the mainland, not as some triumphant homecoming, but as insurance against exactly this kind of catastrophe happening again. In 2023, 20 male Kakapo were moved to Sanctuary Mountain, Maungatautari, a fenced reserve on the North Island, ringed by close to 50 kilometers of predator-proof perimeter. For the first time in more than a century, Kakapo were living on mainland New Zealand, The team spent close to 9 months and roughly $900,000 retrofitting that fence specifically to stop Kakapo from climbing it, because, as it turns out, this is one of the best climbing birds alive, scaling with its beak and claws like it's built for exactly that. The fence held against direct climbing. The birds got out anyway, using overhanging branches to essentially parachute themselves over the top using their wings for lift on the way down. One of them was found wandering down the middle of a rural road by a milk tanker driver at 4 in the morning. Over the following months, bird after bird kept testing that boundary until the team made the difficult call to scale the population back from 10 down to just a handful, simply to make daily monitoring sustainable. It is, almost beat for beat, the same pattern that has defined every single chapter of this recovery since 1995. The program builds a system. The bird tests it, finds the gap nobody saw, and shows the team exactly where their assumptions were wrong. And by 2025, the few birds that stayed have started booming on mainland New Zealand soil for the first time in over 100 years, a trial that is still running right now, with no guaranteed ending either way. Which brings this story to right now, to a number that didn't exist when most of the footage covering this species was filmed. The population entered this breeding season at 236 birds, including 83 females old enough to breed, 4 times the number of breeding females the program started with in 1995. Remu fruited at exceptional levels across the Southern Islands this year. And as this season has played out, it has already become the largest breeding season in the program's entire 30-year history, with chick counts now passing well beyond the old 2019 record and climbing past the 100 mark, the first time that threshold has ever been crossed. None of that happened because the program finally found a way to push harder. It happened because 30 years of failures, corrected one at a time, taught a team of scientists to listen to what a single, stubborn, flightless parrot had been telling them the entire time. We tend to assume that saving a species on the edge of extinction means tightening our grip, more feeding, more monitoring, more intervention layered on top of intervention until nothing is left to chance. This story runs in the opposite direction. Every real breakthrough in 30 years came from learning to do less and to do it with more precision. Feed less, but feed exactly right. Manage less, but manage exactly where it matters. The Kakapo never adapted to fit the program. The program spent 3 decades slowly adapting to fit the Kakapo, and the moment it finally did, the bird answered with the biggest season anyone has ever recorded. And if this is the kind of story you want more of, the comeback stories happening right now that almost nobody else is covering, subscribe to the channel so the next one finds you the moment it goes up.